So far we've seen the product rule, where if you want to differentiate the product of two parts here, then you have to leave u the same, differentiate the v, and then leave v the same, and then differentiate the u. Now comes the quotient rule. Now if you want to differentiate one thing divided by another thing, this is what you have to do. So if you want to differentiate this thing here, you have to leave v the same, differentiate the u, and then leave u the same, and then differentiate the v, and then divide everything by v squared. Okay, so in this video we're going to see why this is the case. Okay, and then in the next video I'll probably give you some examples and some practice. Okay, so in this video we're going to try and understand why this works. Okay, so first start out by drawing your graph here. So this graph could be anything, but the thing is, this line here represents u divided by v. So set up 2 points A and B, and as usual you would put this into this thing here. So that will give you this height here, and then so you putting x plus h into here would give you this. Okay, and then put the x into this thing here. That would immediately take you to this point here. So you putting the x into this whole thing here would take you to here. So that will then give you this. So basically we're going to get this height, which is given by this, take away this height here, which is given by this. So this whole thing here would give us our delta y, if you like, our change in y. So this bit here will give us this height here, and then we've got to divide it by h here, and then to get the true gradient we take the limit as h tends to 0. Okay, so this is our normal routine really. So if you want to differentiate u divided by v, then you have to follow this whole thing here. Now it's just a matter of using algebra now. So we want to merge these two fractions. At the moment the two denominators are different. So we've got to get the two denominators to be the same. So over here times top and bottom by the same thing, v of x. So v of x. And then over here times top and bottom by the same thing, by this thing here. So it's v of x plus h times v of x plus h. And then that will give you this here. Now the two denominators are the same. You can merge the two fractions at the top here. Okay, so merging the two fractions would give you this. So look, the two denominators are the same. That's this here. Now it's just a matter of merging these two. So basically this whole thing here becomes this thing here. Okay, and then our next step is to next step is whenever you have a fraction within a fraction. So here you've got a big fraction here. Within this fraction here you've got a fraction over this thing here. So whenever you have a fraction within a fraction, then visualize it like this. So at the moment you've got this number, well, whatever that is, just think of it as a fraction divided by h, but visualize the divided by h but like this. So you've got a fraction here, and then you divide by h. Now when you divide a fraction, it gets multiplied to the bottom. So it becomes this here. Okay, so it's basically the h gets multiplied to the bottom here. So you got this times this times this. Okay, that would take you to here. Okay, and then the cunning part, just like in the product rule, where you can add. So here you've got a fraction. The cunning part here is to add and take away by the same thing to the numerator. So here, hang on. So here, visualize this as one block taking away another block. So this block here is this bit here. Okay, and this block here is you taking this. So basically this is this here, and then this block here is this block here. But the cunning part is you taking away this and then adding this the exact same thing. So it's like me taking away 3 and then add 3 is similar to that, in that this block here is exactly the same as this. It's just a trick. This is just a trick. So we are basically taking away this block and then adding the exact same block. It's just a trick. So you're just doing that to the numerator. So now oh, so hang on. So we were here. Okay, we were here. So this block here is this block here. This block here is this block here. And then we're just gonna, in between, we're just gonna take away a mystery block and then add the exact same mystery block. So it's the same. So this whole thing here is the same as this whole thing here. So it's just a trick. Okay. The reason why we add this is, well, I'll try and explain it. The reason at the end, because ultimately we're aiming to get to something like this. Hang on. Plus x and then minus f of x here, and then divided by h, and then this is what we're aiming for. Whenever we get this here is a true definition of the gradient. Don't worry about it too much. So from here we will get to here. Okay. So our next step, the next cunning step. So there are two cunning steps in this process. The first cunning step was when we're here. So the first cunning step was when we're here. So this was this here, and then this here is this here, and then the first cunning step is was to take away this and then add the exact same thing. That's the first cunning step. The next cunning step here is to visualize this as one block here, and then visualize this as one block here. Okay, so this here is another block here. The next cunning step is to divide this block by h, divide this block by h, divide this block by h. So it's just a trick. So it's dividing everything by h. So at the moment we've got this block here, and then we've got another block here, and then we've got another block here. Divide everything by h, and you're allowed to do that in algebra. If you have a over a plus b over c, you can, that's the same as me doing this. Divide everything by anything. I'm going to say 3. Divide everything by 3. You're allowed to do that. You're dividing everything by 3. So this is what we're doing. Okay, so here our first block is this one here. We're going to divide this block by h. That will give us this. And then our second block, which was this here, we're going to divide this block by h. Okay, and then our third block here, we're going to divide this block by h. So when you divide this by h, these two will kill off each other, leaving you this. Okay, so that's a second cunning step. Okay, so here because here we've got v plus h behind the v of x. Remember, our aim is to somehow get something along the line of f of x plus h, take away f of x divided by h here. We want this to be in front and then this to be behind, so that we at the moment we've got x plus h behind after v of x. So at the moment it's like we've got this here, f of x minus f of x plus h. We want f of x plus h, take away f of x. Well, it's us wanting this to be in front and then this to be behind. Okay, so our next step is just to use algebra. So it's like so switch these two around. Okay, so remember that this minus belongs to this block here. So this goes in front. Imagine this is a positive. So basically this is the block here. This is the block here. It's just us switching them around. So it's us switching these two around. But you've got to carry this minus with this one, because the minus belongs to whatever's after it. So the minus belongs to this block here. So it becomes this. And then just to tidy this up, take the minus out here. So at the moment you've got this fraction here. Take the minus out, Okay, so it looks like this. Hang on. Take the minus out here. So this here becomes, this positive here becomes a minus down here. And then so when you come to multiply out this minus, this times this will give you the minus block, and then the minus times a minus, that will give you the positive block. So it's just us using algebra to get from here to here. Okay, and then so it's a bit like this here. We were here. We had a minus b over h, and then so we first switch the b and the a around, so that gives us minus b plus a over h. Okay, and then we want it in the form of b minus a over h, so we take the minus out. So from here we would take the minus out, so that would give us b and then minus a here over h. It's just algebra. Okay, well anyway, so from here switch these two around, so that will give you this. Factor out the minus, that will give us this here, and then you're at this stage here, and then once you're at this stage here, let me think. Once you're at this stage here, once you're at this stage here, notice that v of x is in common, v of x is in common here. So factor out the v of x. That gives you this. Okay, and then over in here, notice that this here is exactly the same as this here. That this is in common. U of x is in common. U of x is in common. Factor out the u of x here, leaving you. So you've got one block here and one block here. You see, this is what we were aiming for. We were aiming for the case of x plus h, f of x plus h minus f of x over h. This was what we were aiming for. Okay, so yeah, so once you're here, then if you take the limit of the whole thing here, take the limit of this whole thing here, then by using our knowledge of limits, we can jump into this. So it's u taking the limit of this times u taking the limit of this. So this bit here, hang on. So that would take you to here. So if you take the limit of the whole thing, then from our knowledge of limits, you can actually jump into this thing here. So you taking the limit of the whole thing here is the same as you taking the limit of this. So this bit here becomes this bit here. Taking the whole limit of this here, that's this here. You see, this here is good because this here is really du by dx. But this is a true definition of, well, anyway, this bit here, take the limit of this here, that will give you this, and then take the limit of this here, that will give you this. Again, this here is good because this is the precise definition of dv by dx. Okay, and then you take the limit of this, that will give you this. Take the limit of this, that will give you this. Okay, and then this here, just, well, as taking the limit as h tends to 0 is the same as this here. Now this is a true definition of du by dx. So this here would give us this, and this here, because h is not involved in this, so the limit of u of x is simply u of x. And then this is a true definition of dv by dx. And then the limit of this is just v of x. Now v of x plus h. Now if h tends to 0, then this whole thing here just becomes v of x. Okay, so this here is our well, this whole thing here becomes this. And by the way, this v here pretty much changes to the v because we know that this here is a function of we know inside our minds that this here is a function of x. So we know that this is a function of x, and we know that v on its own is also a function of x because we know that these two are the same thing, so we can just change it to this. Because when we're here, we know inside our minds that v is really a function of x. Same with the u here. We know that if you just write u, it means that, well, it means that u is going to be a function of x. U on its own here, we know that we're going to do something to the x. Well, u is a function of x. So we could write this, or we could write this. They both mean the same thing. Okay. So overall, our quotient root becomes this here. Okay.